Hi viewers, this is Dr. Kavita from SNS College of Technology. So in this session I am going to explain about the hydraulic machines. The hydraulic machines, if you are taking hydraulic machine, it may be a pump or it may be a turbine. So if you are taking that pump, the input will be the mechanical energy and the output will be the hydraulic energy. And if you are taking the turbine, so it will be just opposite to the pump. So here the input will be hydraulic energy and the output will be the mechanical energy. So here by means of the hydraulic machine, we are converting hydraulic energy into the mechanical energy. So here you can see that in dams, we are storing the water in the reservoirs. For the huge amount of water will be stored, and here the bottommost part of that reservoir we will place the turbine, and through the penstock the water from the reservoir will be getting into the turbine. So then the turbine, in turbine there will be the impeller will be there. So once the water is entered into this casing, the vanes will rotate. Due to that rotation, the energy will be converted into the mechanical energy. So this is the energy conversion which is taking place in the turbine. And if you are taking that, the classifications will be according to the energy. So here according to energy, it is an impulse turbine and it may be a reaction turbine. So according to the direction of flow of water, we are classifying this as tangential flow turbine, radial flow, axial flow and mixed flow turbine. And according to the head of water, so which means if you are storing the huge amount of water, or it may be the amount of water will be less. So according to the head of water at inlet, we are classifying as high head, medium head and also the low head. And if the according to the specific speed of the turbine, this is a low specific speed, medium specific speed and high specific speed. So now we will see that. So what is the means of impulse turbine? Here there will be an inlet and there will be outlet. If the at inlet the energy available only the kinetic energy, we are calling that as a impulse turbine. If that energy is kinetic energy as well as the pressure energy, it will be a reaction turbine. Okay, and if the water, that is a flow of water along the tangent to the runner, means we are calling that as a tangential flow turbine. And if you are taking this the radial flow turbine, the water will flow in radial direction to the runner of the turbine. So here is a radial flow turbine. So again in the radial flow turbine, the water is from outward to inward, means we are calling it as a inward. If it is a inward to outward, we are calling that as a outward flow radial flow direction turbine. Okay, and if the flow of water is direction, there is a parallel to the axis of rotation of the runner, means it is axial flow. Okay, so if it is taking in case of mixed flow, the water will enter radially, but it will leave the water leaves from the runner in the direction which is parallel to the direction of rotation of the turbine. It is a mixed flow turbine. And here if you, this is the picture of the penta and wheel turbine. So this is the best examples of for impulse turbine, and here it is best suitable for high head and also low flow rate. Okay, and here the energy at inlet will be the kinetic energy. Okay, and next if you are moving into the radial flow turbine, as we saw that already. So it is classified into inward and outward flow turbine. So what is the inward flow? Okay, so here if you are seeing that the main components of radial flow turbine will be a spiral casing will be there, and there will be the guide mechanism will be there, and there will be a runner, and also there will be a draft tube to discharge the water. Okay, so if I am taking the inward flow turbine, so you can see that the water will which is enter into the turbine from the outward direction, and again it will enter into the inward. Okay, that is a outward to the inward. The water movement will be the outward to the inward. Then we are calling that as the inward flow turbine. And if I am taking that outward flow turbine, first the water will enter in the inward of that turbine, and it will move on to the outward of the turbine. Then it is calling that as an outward flow turbine. And this is the thing, we are taking that as a Francis turbine. So if you are taking inward flow reaction turbine, the best example is the Francis turbine. Okay, and this Francis turbine is suitable for medium head and medium flow water. Okay, and if you are taking that axial flow turbine, so these are classified into propeller turbine and also the Kaplan turbine. Okay, so here if I am taking this here, so this is the propeller turbine. If you are here, you can see that main components are shaft and vanes. Okay, so here in case of propeller turbine, the vanes are fixed, we can't adjust. Okay, so we can't adjust, but in Kaplan turbine, here we can remove this vanes and you can adjust the number of vanes, and also you can change the direction of the vanes also. Okay, so now we are calling this type of turbine as a Kaplan turbine. So thank you for listening this video. So in the next section we will see that detailing one turbine by one turbine.